everyone, I welcome you back to Global Education Zone. And in the past episodes on algebraic processes, we talked about how to factorize and solve a quadratic equation, right? Now in this particular episode, we're talking about how to form a quadratic equation or a quadratic expression. So when you are given the roots of the equation. So how to form a quadratic equation when you are given the roots of the equation. And number two, we'll be talking about how to convert a quadratic equation into a graph and how to convert a graph into a quadratic equation. So those are the three things we're talking about. How to find a quadratic equation when given its roots. Number two, how to convert a quadratic equation into a graph, or rather how to plot a graph of a quadratic equation. Then number three, how to convert a graph back into a quadratic equation. So you convert a graph into a quadratic equation and then a quadratic equation into a graph. So let's take the first part of the video. We're talking about how to form a quadratic equation when given its roots. So quadratic equations, let me give an example. Example 1. Find the quadratic equation whose roots are -2 and +2. Now they said the roots are -2 and +2. Now the root of an equation is what x is. So the root means that x is 11. Sorry, x is -2, and it's also said and +2. So that means x is -2 and x is +2. So if we solve this equation, x is -2, that means x plus 2 is equal to 0, and x minus 2 is equal to 0. So this shows that x plus 2 and x minus 2 is equal to 0. They are factors. They have become factors. So if we enclose them in brackets and multiply, we know that when something is 0, multiply with another 0. 0 times 0 is 0, right? So that means x plus 2, which is 0, x plus 2 multiplied by x minus 2, which is 0, will give us 0. Because the product of 0 and any other thing is 0. So once one of these is 0, this equation is valid. It doesn't even have to be that both of them have to be 0. So either this one is 0 or this one is 0, or either both of them are 0, it will still give us 0. Now we solve this equation, we'll do what is known as expansion. So when we expand this equation, we will multiply each term in the first bracket by each term in the right bracket. So let's take the first term in the first bracket, x. So let's multiply x by every term in the second bracket. That means x times x will be x squared. X times -2 is -2x. Then we'll take the 2. 2 times x is what? That's plus 2x. Then 2 times -2 is -4 equals 0. That means x squared minus 2x plus 2x, that cancels out. That will be x squared plus -4 equals 0. So this is the quadratic equation we have formed from this statement. Now, moving on. Now, how do we convert a quadratic equation into a graph? Now, using the same equation, we are going to convert this into a graph. So let's start from there. Now, what you do is you plot the values of x and y, the corresponding values of x and y. So let's plot the values. Let's plot the graph of this equation from x is -3 to x is +3. So let's say if x is -3, when x is -3, 3, when x is -2, -1, 0, 1, 2, and 3. Then when x is -3, what will y be? So let's plot the complete table though. When x is, we'll plot the values of x. Then which other thing is on this table? We have x, so we'll calculate the squares of x squared. We'll look for the corresponding values. Then we'll look for -4 as a constant. Then finally we'll evaluate y. So this will be the total table. So let's complete this table ourselves. You and I, let's do that. Now, when x is -3, what will x squared be? X squared is the square of x. That's -3 squared. That's -3 times -3. That's +9. When x is -2, -2 times -2 is x squared. That's +4. When x is -1, x squared becomes -1 times -1. That's +1. When x is 0, x squared is 0 times 0. That's 0. When x is 1, x squared is 1 plus 1 times 1. That's 1. When x is 2, x squared is 2 times 2. That's 4. When x is 3, x squared is 3 times 3. That's 9. Next, we have the -4. The -4 has been a constant. It is filled constantly throughout every row of the table. That's -4. Everything with -4, -4, -4, because it's a constant. -4, -4, -4, -4. So you fill your constants equal throughout the the constant row. Then lastly, we have the y row. So for this y row, we are going to evaluate x squared minus 4, meaning you add these two terms together. X squared minus 4 for this column, that's plus 9 minus 4, that's plus 5. X squared minus 4 for this one is plus 4 minus 4, that's 0. For this one, that's plus 1 minus 4, that's minus 3. Plus 0, sorry, that's 0 minus 4, that's minus 4. 1 minus 4, that's minus 3. 4 minus 4, that's 0. 9 minus 4, that's 5. So let's plot the graph. So basically, you have your y-axis and your x-axis. This is your positive y-axis in the upward direction. This is your negative y-axis in the downward direction. This is your positive x-axis in the right direction, and this is your negative x-axis in your left direction. So you denote this as plus y, minus y, plus x, and minus x. So when x is, so this is just a sketch of a graph because I don't have a graph sheet right now. So let's put number minus 1, minus 2, minus 3. So the values on the left side of this x-axis are going to be negative. Then the values on the right side will be positive. 1, 2, 3. This will be positive. Now moving on, when x is minus 3, what is y? Y is plus 5. So let's represent this. Let's divide the y-axis into 5 units. This should be 5. 5 up and 5 down. This should be 1, 2, 3, 4, 5. Then we have 1, 2, 3, 4, 5. So this plus 1 plus 2 plus 3 plus 4 plus 5 minus 1 minus 2 minus 3 minus 4 minus 5. So I must remind you that this is just a sketch. So for this sketch, we are just going to be sketching the values. So when x is minus 3, y is plus 5. So you trace minus 3 and plus 5. This is plus 5. You trace plus 5 to the left. You trace minus 3 upward. So where they intersect, they give you the point. So when x is minus 2, y is 0. So minus 2 comma 0. So this is the point where they intersect. So when x is minus 1, y is minus 3. Minus 1 and minus 3. Minus 3 is a negative one, so it's downwards. So this is minus 3. So I'm representing them by circles. So you can, if possible, I guess you'll be able to see circles. Then when x is 0, y is minus 4. So this is 1, 2, 3, 4, minus 4. When x is 1, y is minus 3. That's 1 and minus 3 when they intersect. When x is 2, y is 0. That's 2, 0. When x is 3, y is 5. So if then you use your pencil, if you are with a graph book, use your pencil to draw a straight line through each of these points. Sorry, a curved line rather through each of these points. So you get the shape of a parabola, and this is called a quadratic graph. A quadratic graph has the general shape of a parabola, and we'll be doing parabola. If you are interested in that, we'll be doing it in the further mathematics series, which I'm about to cover in this channel. So we'll wait for that. So this parabola, it represents the shape of this graph. So and then we've successfully drawn a graph from this equation, right? Now what if we want to get this equation back from the graph? Assuming we are not given this equation x squared minus 4, I want to get it. So what you do is you are going to use the root of x, and the root of x are the point where this graph cuts the x-axis. So where does it cut the x-axis? It cuts the x-axis at minus 2 and plus 2. So that means you can say x is minus 2, x is minus 2, x is equal to minus 2, and x is plus 2. So when you evaluate it, if x is minus 2, that means x plus 2 is 0. If x is minus 2, that means x plus 2 is 0. Then next, if x is 2, then x minus 2 is 0. So when we multiply both, that means x plus 2, since they are factors, x plus 2 multiplied by x minus 2 will give us 0. So you can see that this is the same equation as the one we had here, which simplified to x squared minus 4. X squared minus 4 equals 0. So if you use the roots of the graph, you are going to get back your quadratic equation. So this is how to generate a quadratic equation from the root of the equation, which I solved here in summary. Then next, this is how to generate a graph of a quadratic equation using the table of values. So this is how to do that. Then lastly, this is how to generate the initial quadratic equation by taking the roots of the x-intercepts on the graph. So you still get the initial equation, and these three methods are connected together. So thank you for watching this far, and don't forget to like, share, and subscribe.